Hi friends, welcome to follow up. Let's have a look at an easy problem, problem 2765, longest alternating subarray. In this video, we're going to explain a solution based on DP, or you can interpret as just a for loop. So here the problem is the following. So we are given a zero indexed integer array called nums. So we want to find the length of the alternating subarrays. We want to find the maximum length. So if there's no such alternating subarrays, we need to return -1. So here a subarray S of length m is called alternating if we consider their difference. So the differences should be +1 or -1, but it starts from +1, right? So S1 minus S0 equals 1. So as such, if we have a valid alternating subsequence or subarray, so here we should consider subarray. So it's at least 2 for the return, right? So here we have two examples. So in the first example, we can see we have 3, 4, 3, 4. So the length is 4, right? We cannot include this 2 because 2, 3, 4 is strictly increasing, right? So in the second example, we have 4, 5, 6. So 5 minus 4, so we have 2, but we cannot include 6. So similarly, we can think of 4 and 6, 5 and 6, but we cannot include 4. So the output is 2 for this example. So here the constraints are the following. First, the length is at least 2, and it has an upper bound 100. So this 100 is not very large. So in such a sense, maybe one can try brute force. In other words, check each subarray as in the hint, but we are not going to do this. Secondly, this is the elements bound in the nums list. It's bounded below by 1 and bounded above by 10 to the power 4. So this is not that essential. So for this problem, because we want to consider alternating sequences, so our strategy here is to find valid alternating +1, -1 subarrays in the difference subarray. So we are going to use dynamic programming or just a for loop. So we are going to interpret DPI. So it's the maximum length of the above difference subarray ending at a certain index. So here let me explain the logic while we do the coding. So first, let's get the length of this nums array. So this is just for convenience. Notice that in this problem, n is greater than or equal to 2. Then, if we consider the difference difference array, so it has a length at least 1, right? So now let's consider this difference using list comprehension. So we're going to have nums I minus nums I minus 1. So for I in range, so we're going to start from 1 and ending at n minus 1, right? So this is the difference sequence. So now let's look at DP initialization. So we're going to use 0 times n minus 1. The reason is that this diff array has length n minus 1. So so this is a diff. So now let's first set up the first one element. So because we know the valid alternating subarray should start from S0 as this condition. In other words, the first difference should be 1. So we are going to say if diff 0 is 1, then we are going to set dp 0 to be 1, right? So for the return, we are going to find the maximal dp value, then +1, right? So this is the initialization. Now let's look at the dp update. So we're going to iterate for I in range from 1 to n minus 1, right? So this n minus 1 actually is the length of this diff sequence. So first let's consider a case that is diff I equals 1. So if diff I equals 1, so anyway, this index can be regarded as a start. So in other words, the dp at this index is at least 1. So now what we want to check is if we can extend the previous one by adding the current number in the diff, right? So if diff I minus 1 is negative 1, and also this at index I minus 1, it's in between a valid alternating subarray. So this is going to see that dp I minus 1 is greater than 1, right? Because dp I minus 1 is negative 1. So if this number is 0, it means that this is not in the middle of a valid alternating subarray in the sense of this problem. So if this condition holds, then we're going to set dpi. So we can extend that. So that is dpi minus 1 plus 1. So that's the one. All the other cases, so either def I minus 1 is not 1, or dp I minus 1 is 0. In that case, so we should regard this as a start. So we are going to set dpi to be 1, right? So this is the case for difference equals 1. So this is very special because in the problem, once the diff is 1, we have a length at least 2. For example, this for 5 case, right? And then we consider another case, else if. So if diff I equals negative 1, right? So in this case, we can only pick 1. If diff I minus 1 equals 1. So in this case, we can extend, right? So it means diff I dpi equals dp I minus 1 and plus 1. So all the other cases, so because it's not 1, they cannot regard it as start. We keep dp to be 0, right? At the index I. So similarly, in this larger if-else block, all the other cases should remain dpi to be 0. So we do not make any code. So or we not write any code. So this way we finish the dp update. So this is dp initialization and this is dp update. Then we would like to prepare the return. So we want to return max dp plus 1. So here plus 1 is that because this dp is for the alternating subarray. So for the difference, then we add 1 back. So if max dp is greater than 1, greater or equal than 1, it means that we have 1 at least, right? Because it's possible, right? So the difference is not 1 or negative 1. For example, you have an array that is 4, 50, 60, right? That's actually you have negative 1. So this else we are going to return negative 1. So this actually forms a solution format to this problem. So now let's do a test. Yeah, it passes the first example. Now let's look at a special case, like example 1. Let's write 3, 4, 5. So this should return 2, right? Yeah. So let's pick 1, which should return negative 1. Yeah. So now let's look at the generic case. Yeah, it passes all the test cases decently fast. So now let's change a little bit. So we are going to introduce a running variable to avoid this max, right? So we are going to use this one as v1. And now let's introduce a running variable. Let's see. We are going to do this. Let's do this maybe. Result equals negative 1. And then let's see, result equals 0. Now let's so result equals max result dp 0. So similarly here, so we're going to do after we set dpi, so result equals max result and dpi, right? So then we just need to return result plus 1 if result is greater than or equal to 1. Otherwise, we return negative 1. So this way, we use a running variable to do this, right? But I guess this becomes messier because here we just use one max. So now let's do a test anyway. Yeah, it passes all the cases. So with that said, basically the first version is the one we want to present for this specific easy problem by LeetCode. So you are encouraged to try other variants of this code or come up with other solution idea. Thank you.